today's lecture, okay, today's class. Okay, what I've done is actually taken from the same set of slides and trying to simplify and also trying to look at what is more important, and also so that you can be focused on what you need to actually do, okay, or look into. So by the end of this lesson, this short-term scheduling, or you can call it operations scheduling, short-term scheduling, hopefully you'll be able to explain the relationship between short-term scheduling, capacity planning, aggregate planning, and master scheduling, which we have been doing a lot since like 4-5 weeks before, since we started to talk about aggregate planning. Okay, and the tools. Okay, and that the next thing is the tool. We need the techniques. So we have Gantt chart, Gantt loading, schedule charts, and we have another tool which is actually assignment method, which is related to loading. Okay, so applying the assignment method for loading jobs. So, and continue with that, we're going to understand sequencing rules. Okay, all these are related to scheduling. Of course, we need to understand the concept of scheduling first before we can do we can apply the tools and techniques. And also a special sequencing tools, we call it as Johnson's rule. Okay, Johnson's rule. Right. So first question, before we talk about all the details of what is scheduling in operations? What is scheduling? Or in general, what is scheduling? Anyone? The book starts with a story about scheduling flights, airline flights, when weather is the enemy. Okay, so you can read the case study. Scheduling. What is scheduling? What is scheduling? A very simple word, simple explanation. Yu Hong.
It's a plan.
It's a plan. Okay, it's a plan. Okay. Other than that, who? It's a plan. Is a. So if you schedule your day today, schedule your day that you start my class 9 to 12, 9:40 to 12. So it's a plan. It's something that you want to do. Betul? Correct. Sorry.
Yes.
Okay. So in operations, you imagine we want to make parts, components, or we need to deliver. So what's the element? Time element. I've given you the answer. There is a time element. Okay, it's a time element. Okay. Okay, Yule, anything? Any opinion about scheduling? Any what is scheduling? It's a simple,
Kind of timetable.
Exactly. Okay, good. Timetable, kind of timetable, kind of, what are things that need to be done. Okay, for example, this is the things that need to be done, and this is the time that is required. How long does it take to do it? Okay, so we want to schedule. We want to, make sure that we can meet what are we trying to meet? What are we trying to achieve? When you make parts, there are customers, right? Someone is ordering your parts. Someone is demanding. So you must meet their what? Now, if you request some service or you you want to buy certain products, you are the customers. So the manufacturer give you some promise that they will be able to deliver to you on a certain deadline. Okay, deadline. What is deadline? Fangi, what is deadline?
It's a time that you're supposed to hand in your.
Yeah, it's a promise time. It's a it
Promise
is in a real life. For example, okay, I'm not picking on you. Okay, I'm not finding your mistakes. For example, you did not submit your assignment on time. In real life, you're losing business. You are going to lose business. Someone doing business with you, and you promise that you want to deliver it on this deadline. For example, you want to deliver the product, okay, 50, I can send to you. If in real life, you will lose trust with the customers. That means with the manufacturers. But it's okay, in university, you can make all the mistakes in the world, no problem. You make, it's a learning process for you. So deadlines are very important for manufacturers to actually maintain their reputation. Do you understand reputation? Do you know the wording, the meaning of reputation? Yuki, reputation wa nan desu ka? Reputation. Oh, you know reputation. Fangi, reputation. Contoh Google test gimana? Reputation wa nan desu ka? Reputation, R-E-P-U-T-A-T-I-O-N. Reputation. Yes, anyone? Reputation.
I don't know how to explain it, but I know what it means.
評価。
評価は何ですか?
評価
That
は、
the other people, other people
Believe in you. Okay,
yes,
reputation.
how much
Believe,
do they?
how do you actually, assess your capabilities? Reputation. Okay. No, it's okay. It's okay. I'm not picking on you. That's why I say I'm not picking on you. I'm telling you in real life. If you work in industry, Toyota, Honda, they have a high reputation of delivery on time. So they must think about scheduling. Okay. So planning is one thing, but now this is the day-to-day scheduling. The MRP is just a plan. Remember we talked about MRP? MRP is just the overall planning. Okay, 1 month, 2 months. But now we are talking about how to actually make sure that you can actually make and you need to actually decide when, where each operation is necessary to manufacture the product. Okay, so that is the meaning of scheduling. And also it's establishing of times to begin and complete each event or operation comprising a procedure. Okay, so that is in for example 7-Eleven also, they have scheduling, they have when to start, when to finish, the arrangement of not parts, their goods, their items on the shelf. They need to, so someone need to do it. You need time, you need resources. If the job require machines, then you need the machine to do the cutting. For example, you want to, make shirts. You need the raw material must be cut. Then after it's cut, it goes to the first, stage. So when is it going to go to the first stage? So these are the things that, that is important. So the objective of scheduling is actually to allocate and prioritize demand generated by either forecast or customer orders to available facilities. It's not the same meaning. How are you going to actually schedule our machines? Because these are our facilities. Okay. So it's like this, your capacity planning, your long term. Okay, long term. This is long term, years. Change in facilities, new machine, and so on. So you adjust capacity. But then you go to aggregate planning. We have talked about aggregate planning. You talk about master schedule. So this is just a master schedule for bike production, for making the products. Okay. Then you talk about short-term scheduling, days, hours, minutes. This is the daily monitoring. So you have loading, work center loading, job sequencing, and so on. Okay, so this chapter is actually about short-term scheduling, which is actually this. How do we, if you look at the picture here, this picture, then you see how many men do we need, how many hours, when will it start? Work center 6 will start at Monday at 8 o'clock. Okay, and probably we need to run that for 1 day, 2 days. Okay, it is how we assign to specific personnel and work centers. Okay. So I'm not going to detail this, but this is the importance of short-term scheduling is in terms of efficiency and effectiveness. I mean, if you are very competitive, you know, it can be a competitive advantage to the company if you are excellent in scheduling and meeting your your customer demand. You promise to make 50, you can deliver. So, and also if you're good scheduling, the facility will move the raw material faster movement of goods through a facility. And additional capacity, efficient resources will actually faster throughput. Throughput means how much you produce and go out of the factory. You don't want your process time to be too long. Okay. And good schedules result in more dependable deliveries. Okay, so that's why we need effective and efficient scheduling. But today there's a lot of automation. I'm not denying it. Okay, there's a lot of software. There's a lot of apps, applications for you to do scheduling. Okay. So scheduling means to decide the timing. First, timing. When to start, how long to do. Okay, because we have times to do things, to allocate machine, and how do we prioritize? Prioritize means which to start first. Okay. Okay, there are in scheduling, we can think about either forward or backward scheduling. That means you think from the due date and you work backwards. Or you work forward. That means I get the order today, then I will plan, and load my machines and follow the timeline. Okay, so that's first thing that we need to understand. Either backward or forward scheduling. Of course, both have different advantages and disadvantages. Whether we're talking about finite or infinite. Finite means very fixed, okay. We have only machine, we have only 5 machines. We only have 2 cutter, so that's finite. Finite means very fixed. Infinite means you have a continuous process, infinite loading. And the criteria we can use for sequencing. When we sequence a job, which criteria we should be using. Okay. So in organization, these are all the scheduling decisions. So many scheduling divisions. Hospital, operating room use. Okay, universities, we need to schedule the classrooms and the student and lecturer schedules. Okay, of course for production of goods, purchase of materials, workers. So this managers in operations will actually be involved in making decision on this. Okay. So when we talk about forward scheduling, forward means start as soon as the requirement is known. If I get the order, then you do the, it's forward. So you see the arrow, right? Forward. That means you actually start planning, not start planning, start scheduling, okay? And you try to produce schedule, even though it may not meet the deadline. Because things that come in, I have one more order coming in, new order coming in. So which one I should do first? Or you do first come, first serve. The first order come in, you do first. Okay, so that's forward scheduling. Problem is, it will result in work in process inventory. Because you do, according to forward scheduling. So opposite to this is backward scheduling. So backward scheduling, you mean start from the due date. What is the, request by the customers? What is the due date? So if you know, you will be given the due date. All orders will have due date. Okay, and you schedule the final operation first, and you start backwards. So due date, and you move this way. So you schedule like the MRP. Okay, is backward scheduling. So the disadvantage is resources may not be available to accomplish the schedule. Okay, because if we have too many work to do at the same time, then you may not have the machine or the people or the workers. Backward scheduling. So often these approaches are combined. So it's not just using forward or backward alone, but it is normally combined. Okay, to develop trade-off between capacity of constraint and customer expectation. So we can have some rules. Okay, some rules to actually decide whether we can which one to do first, which jobs to actually execute first. Okay, the concept of finite and finite loading. So when we say finite loading, so loading means assigning job. When we say loading means I want to assign. Okay, we have a Google Calendar, right? Do you have a Google Calendar? Do you use Google Calendar, or you use your Apple Calendar? So what do? You put in your schedule. You load means you block. For example, Wednesday, this time is my class. This I got meeting, or this one I'm going to go to the movies. So you load. Okay. So that is finite. You only have 24 hours a day. You don't have 60 hours a day. Finite. Okay, fixed. So assigning job to workstation, finite. You assign work to the capacity of the workstation, because machine have a certain capacity, and all work gets done based on your that limit. But and due dates may be pushed out. Okay, you can result into due dates. That means you cannot meet the deadline. Okay. And another one is infinite loading, does not consider capacity. All due dates are going to be met. Capacities may have to be adjusted. So this is a bit tricky, a bit difficult. But normally for mass production, line production is okay for infinite loading. Okay. Right. What are the criteria that normally being used for deciding on schedule? Okay, there are four criteria. What are the criteria? But of course, the correct scheduling technique that we use depend on the volume of orders. That means how much order we get, and as well as the nature of operation, the nature of process, and complexity of the job. But basically, anything that we try to do, if you want to schedule, you are going to minimize your completion time. Do you understand the minimized completion time? Okay. Fangi, can you explain minimized completion time? What do you understand?
Well, I think maybe as fast as the worker or the planning can to finish the whole schedule.
The whole order, okay, not schedule.
Yeah, whole order.
Orders. So we have to think about orders, right? We have 10 orders. So one order may take 5 days, another order may take 10 days, another order, because different orders. So we want to minimize the completion time of all our orders or demand. Okay, demand. Okay, right. So this can be evaluated by calculating the average completion time. Okay, in the book it's written, evaluated by determining the average completion time. Okay, so we have a measure now. We can measure. If I know the average completion time, I know that is a good method. Okay, maximize utilization of facilities or machines. This can be determined by the percent of the time the facility is used. If your machine should run 8 hours, but it only runs 4 hours, you're not paying for the machine. You're just, machine is doing nothing, not making money. Understand? If I have 5 machines, and when job orders, I need to sequence so that all the machines are being maximally utilized. Understand? Okay. So maximize, you can measure that by percent of the facility being utilized or used. Okay. So another one is minimizing the work in process inventory. The more work in process, meaning there's a lot of delay. If I 10 orders, the work in process, this one will be in the system. Be in the system, it doesn't go out completed. It's still being, processed. So you want to minimize that. So your scheduling must, okay, what's the measure for minimizing work in process? How can you evaluate work in process inventory? Now, Yu Hong, how do you evaluate minimization of work in process? Page 642 in the book. Page 642 in the book. Minimize work in process inventory. Anyone found it? Anyone found the answer? What is the measure? How do you evaluate minimization of work in process? Or Ho or Yuki?
Oh, well, evaluate by determining the average number of the jobs in the system.
Okay, so you determine the average number of jobs in the system. Okay, we'll see this example after this. I'm trying to tell you the concept first, so that after this, the method will actually, when you do the calculation or you see the calculation of the method, means, oh, this is calculating the average number of jobs in the system. Okay. Now, so that's one measure. Okay, and the higher the worse it is. Okay. You want lower. Okay, you want to be low average number of jobs in the system or the number of jobs in the system. Obviously, minimize customer waiting time. So how do you evaluate that? You can use a measure which is called average number of late periods or lateness. We call it lateness. Okay, we can measure lateness by looking at their end dates and how we actually, if the end date is day 10, but we only complete in day 12, then of course you are 2 days late. Okay, we'll see that example. Okay, now This is just showing the different types of, scheduling that you can actually do. So for process focus, you have to schedule orders. For repetitive facilities, for assembly line is the easiest to schedule. Very easy to schedule assembly line. Line on and it will go. It is scheduling the module. For finished product also is quite easy. Okay, so you schedule the finished product. But the most difficult scheduling is actually in job shops. Process focus. And you need to schedule orders. Okay. And of course, it depends on the number of input, the number of n items and so on. So different process strategies, different focus for scheduling. So if you go into, I'm going to go process, okay? We're going to focus on process first. No, this is actually process focus scheduling, okay? So process focus is high variety, low volume, schedule orders without incoming order without violating capacity constraints. That means we need to make sure the orders come in and we can meet their demand. Okay, our capacity is enough, right? And again, I said scheduling is difficult, can be complex in high variety, low volume. Okay, so the job that arrive, we call it loading jobs. Okay, loading job means you assign a job or you assign the orders. Basically, assigning means you start doing the job or doing the work. So assign jobs so that cost, idle time or completion time are minimized. Okay, like the measures just now. So we want to make sure that you do not, result into idle time. Idle time means the worker is not working, the machine is not running. Idle time. Idle means nani mo shite nai yo. Idle time. Okay. There is two forms of loading. One is depend on capacity. We call it capacity oriented. And another one is assigning. We call it assignment. Okay, you assign specific job to work centers. Okay, so when you do loading means loading now is already we're talking about scheduling already. Okay, loading means we are going to actually schedule. There is a method, but I'm not going to go to this detail. Okay, it's called input-output control. It is it's like this. Okay, it's you can look at the example in the book actually. Okay, the example is they have this so-called input-output control of how much they have produced, their plan, and the actual, and they look at their cumulative deviation or changes. Okay, so input-output control quantity. Okay, for example, on the 6th this week, 6/6, 270 input, 270 output, 0 change. That means there is no backlog. But in the second week, there is a 20 backlog, minus 20. Okay, so this is a way of actually looking at the amount that still not being able to be produced. Okay, it's input-output control. It's in example 1. Okay, now I'm not going to go this detail on it, but this is it is used. You can actually use this to correct performance or to increase capacity, and you can increase or reduce input to the work centers so that you meet your demand. Okay, demand requirements. This is in loading. Okay, when you load your machines, input-output control. Another way is Gantt chart. Gantt chart is the most common, quite common, or you have seen this before. The one that I showed you earlier when we start just now is Gantt charts. Okay, this is Gantt charts. Okay, Gantt chart are just the work center. Okay, it shows the loading and idle times of department, machine, people, facilities, and this it will display relative workloads over time. If you want to do your project, for example, so you say this is the first activity, it requires 1 week, then you make the bar, okay, or even some software will be able to show you the Gantt chart. Okay, this is actually Gantt chart, and it will schedule it will show the schedule chart which you can use to monitor your jobs. You can monitor your activities. But Gantt charts need to be updated frequently. Need to update, meaning you need to put in new information, changes, and so on. Okay, so this is a type of Gantt chart. So you load your time, or even in your schedule, daily schedule, you can create a Gantt chart. Okay, and it becomes your schedule. So Monday, Tuesday, Wednesday, Thursday. So this is work centers 1, 2, electronic painting. So job 349 will be done on Monday. Job 350 will be done on Wednesday, Thursday, Friday. The center is not available, doing some other maintenance probably. So this is loading using Gantt chart. Okay. Another convention, this is also a Gantt chart, but it shows start activity, end of activity. So this is the start activity until here, and this is now. So you have check whether you have achieved your online on time or not, whether you have completed or not. So this is a way of scheduling and monitoring your activities. Okay, right. And then the one that I'm going to go and explain in more detail is the assignment method. Now, assignment method is a special type of linear programming. Okay, linear programming is a tool. Basically, it's a tool to actually assign your jobs to resources, your activities to resources. Okay, what's the meaning of assignment? Assignment, not your homework. Homework is assignment. What's the meaning of assign? Assign. Here, assign. Assign means what? Panggil.
The job you have, you're given.
You are going to give. Assign is to give. Okay, other than that, assigns. Nihongo wa nan desu ka?
Kubaru.
Barun? Kubarimasu? Okay. Have you seen this word before? Another word. These are all similar meaning. Designate. Designate. Allocate. You determine. Determine. Determine is also same. Determine. Nihongo wa nan desu ka? Saki. Wariate? Wariate. Wariateru.
Wariateru, yeah.
Wariateru. Allocate. Wariateru. Okay, so it's how we are going to allocate jobs But the objective is minimize cost or time. So we want to allocate, but we want to minimize. And in assignment method, only one job is assigned to only one machine or project. So it is a one job or one worker, one N1, M1, not one job, 10 machine. No, this is one. Okay. Of course, we have many machines. So for example, you want to, of course, you need to have this estimate of cost of doing a job for different job centers or operators. So we have a table of costs associated with the assignment, doing the job, or completion that. So this is in example 4. Okay. So each printing wants to find the minimum total cost assignment to 3 jobs, to 3 typesetters. Okay, A, B, C is 3 typesetters, 3 workstation. R34, S66, T50 are the something like the orders. Okay, orders. If I do R34 at A, it will cost me 11. If I do it at B, it will cost me 14, and so on. Okay. So the rule is like this. First, okay, we will go through this slowly. Create zeros opportunity cost by repeatedly subtracting the lowest cost from each row and column. Okay, I repeat, we need to subtract the lowest cost from each row and column to find the zero opportunity cost. Because at the end of the day, we know which is the cheapest by subtracting that. Okay, so unless you must repeat this basically. Basically repeat this. Number 2, draw the minimum number of vertical and horizontal line which covers all the zeros, which we have done the subtraction. We minus and then we draw the line, and you see if the number of line equal the row, then we have reached optimize. Okay, so that's why I say proceed to step 4, which is actually optimized. But if you are not still having, for example, there is 4 rows and 3 columns. Okay, sorry, 3 rows, 3 columns. Then you need to have 3 lines. Okay, to proceed to step 4. If not, you continue. You need to go to step 3, which is actually subtract the. You need to do the next iteration. That means those uncovered line. What is the smallest number? Then you deduct. Okay. Add the same number to any number at the intersection. So the intersection of the lines, you add the numbers. So these 2 things, 2 different things. Okay, I will show you after this. Or you can see the example in the book. Okay. Then return to step 2 again and repeat this until you get that means you can do for, endless, 4 machines, 4 operators, and so on. So as optimal assignments are at 0 locations in the table, and you select one, draw lines to the row involved, and continue to the next assignment. So what we do is, okay, let's look at this example. Okay, this is the original table. Okay, don't be confused. This is the original table. If you look at, okay, we'll start with rows. If you look at the first row, which is the smallest number? 11, 14, 6. Which is the smallest number? Which is the smallest value? Fangi?
6.
6. So what the step says, deduct all these numbers, 11, 14, 6, with the lowest numbers. So 11 minus 6 become 5.
5.
14 minus 6 become 8. So this is the table that you're going to create by looking at the rows. Rows. Okay. So 6 minus 6, 0. Okay. And you do that for the second row. What happened now? What is S66A here. So the smallest is 8. So 8 minus 8 is 0. 10 minus 8 is 2. 11 minus 8 is 3. So that's what you get this table. Okay, you get this table by deducting the what do you call so-called rows. Start with rows. Okay, then you forget about this table. You move on to this table now, rows. There are okay, you draw a line here, okay, crossing here. So there is how many lines that you can draw that covers the row, the zero. Okay, let's cover the zero. It's still 2. Okay, okay, sorry. We repeat that for columns. Now we repeat that for columns. The smallest number for column 1 is 0, so it doesn't change. 502. Now, column B, column. This is column. So smallest number is here, 2. So you deduct all the numbers from 2. So it becomes 603. Because 8 minus 2 is 6. 2 minus 2 is 0. 5 minus 2 is 3. Here is still the same. 0, 3, 0. You know, 0 is smallest. Okay, so you cannot what do you call, change. It doesn't change anything. The opportunity cost is still 030. So the next step is what does it say? It says that here draw the minimum number of lines, vertical and horizontal, minimum to cover all the zeros. So what are you doing here? So that's why in the table there is in the book. Okay, you will see this line be created. Okay, the lines in step 2. Why this line? Because this line cover cross. You cross 0, 0. This also you cross out 0, 0. Because the remainder doesn't, there is still non-zeros. So how many lines have we created? How many lines have we drawn? Only 2 lines, right? Only 2 lines are needed to cover all the zeros. So the solution is not optimal yet because we need 3 lines because there's 3 rows and 3 columns. Okay. I'm showing you the simple assignment or linear programming method only here. There are, of course, more complicated than this. This is just the simplest one. This is the simplest one. Okay. So the next step is the smallest uncovered number is 2. So among these uncovered numbers, meaning among 5, 6, 2, 3, the smallest is 2. So the rule says, because these are rules, the rule says deduct that from there. So what happened is that don't deduct the ones which are actually cross lines. Okay, you only deduct those not covered by the line. So that's become 5 minus 2 is 3, 2 minus 2 is 0, 6 minus 2 is 4, 3 minus 2 is 1. That's what you get this number from here. When you subtract it, so this is the new table. So the new table now, what you do? You repeat the process of drawing the line. So how many lines can we draw now? How many lines can we draw? We can run 1 here, yes, 1 here, 2 here, and we need another line to cover this additional. Okay, so any zeros which are not drawn or not covered. Oh, sorry, I forgot another important point. Actually, to add the one which is actually cross section. 3 plus 2 is 5 here. Okay, fine. Anyway, so this is the final table, which is actually, so you have 3 lines. So therefore, it is optimum. We have come to our final solution. Okay. So what we have done, or you can draw these 3 lines, is the same thing. Okay, it's, you can draw this way or that way. Okay, same 1, 2, 3. Okay, as long as covered all the zero. Okay, I draw it this way, but you can draw it same answers. So because 3 lines are needed, the solution is optimal. And now you can do the assignment. Now you can allocate. Now you can actually determine. So what we do is, in order for the minimum cost, okay, so you start by assigning R34 to worker C, because okay, there is 3 here, 4 here, 0 here. Obviously, you're going to assign the lowest, smallest cost to the ones which are actually available. Can you assign, is it cheap to assign to A? No, you still need to, there is cost there, there is cost here, but the opportunity cost is 0 here, okay? So that's why R34 assigned to C. So that's our first. And S66, once you assign to C, is no more available for what do you call assignment. Okay. Now, because it's both typesetters and jobs. So S66, who should you assign to? A or B? Can I assign to A? Well, according to 0, you can assign to A, 0. Okay, if you assign to 0, then T50 will fall to B, which is occurring 1. So that's why it's not logical to assign S66 to A and T50 to B. Therefore, the only one available which will give you the minimum cost is assigning it to B.
And left the 0 to T15 0 to A, right?
Exactly. So T50 will be left for A because C is already taken. So this cannot be assigned. You cannot assign to C. So you only assign T50 to A, S66 to B, and R34 to C. Okay. So this is assignment method which will minimize the total cost. Remember, the initial cost was this table. Okay. So what we actually have done is we have assigned T50 to A, S66 to B, and R34 to C. Therefore, the actual cost is actually total minimum cost. Total minimum cost is the additional of, is the summation of 6 and 9 plus 10 plus 6, which is 25. Okay. You can check inside here. If you assign A 11 plus 10 plus 7, no, it's not minimum. So rather than trying to figure out trial and error, find, no. But this is the method. This is it's already a heuristic. It's a heuristic to actually get that. Okay, so finally this is the answer. From the original cost table, the minimum cost is 25. 9 plus 10 plus 6. Okay, so this is a simple, just 3 by 3. You can have 4 by 4, 10 by 10, or at the end of the day, you can just put it into a Excel sheet to actually do it. Okay, this is called the linear programming assignment method and loading. Remember, we're talking about scheduling. Okay, now. Okay, let me go on because there's quite a few things actually that need to be explained in this chapter actually. So once we have done with the loading, we need to think about sequencing. Okay, sequencing is trying to, how shall I say? Okay, what is sequence? Sequence. Oh, sequence wa nan desu ka? Sequence. Jumban the show. Jumban ni dochiraga
Yes.
ichiban i.
Yes.
Jumban.
Jumba.
If I have 5 jobs, so
First to the fifth.
which is which is good to do according to different rules. Okay, different rules. So it actually
Yes.
specify the order. If I have 10 orders, 5 orders, so we move on. Don't think about assignment already. Now we talk about sequencing now. So we want to specify the order in which job should be performed at work centers. And we are going to use these rules. We call it priority rules. Priority rules to dispatch or to sequence. First come, first serve. Okay. So I'm going to find whether first come, first serve is the fastest, cheapest. Is it shortest processing time? So jobs come in with their process times and also their arrival. First come, first serve mean the first customer come or the first order come, but the first order is requiring due date on the 15th of December. Another customer comes say, no, I want this on the 30th of December. Okay, so you have also due dates. There's a difference between first come, first serve. First come, first serve, it depends on who comes first, but due date is actually depending on who want it first. Okay, who wants to the order. Or because there is a processing time, so it's you can start with the longest and see how you're going to actually result into the measures. Okay, the measures. So when we sequence, we can do some comparison. We can do some comparison between these priority rules. Okay. So imagine now this is if you can refer to because there are the performance criteria, average completion time, which is the sum of total flow time divided by the number of jobs on page 649. On page 649, you can see the average completion time, the utilization, the average number of jobs in the system, and the average lateness. Okay. And in example 5, it says 5 architectural rendering jobs are waiting to be assigned to Avanti SETI architects. Their work, they mean their processing time, and the due dates are given in this table. So this is the processing time, that means in terms of days, and the job due dates. Okay, due date means it is required on day 8. This is required on day 9. Okay, we don't have the actual dates, but this is just for example purposes. We want to see the differences between the frequency rule. Okay, so you have these due dates and you have the processing time, and the company wants to determine the sequence of processing according to the 4 priority rules, according to first come, first serve, shortest processing time, due date, or even longest processing time. Okay. And jobs were assigned a letter. Sorry, this is the job. This is so-called the sequence of first come, first serve, basically. This is in terms of job A came first, next the job B. So this is the sequence of arrival, okay, job arrival basically, or order arrival. Understand? You understand how? Job arrival. You understand the concept that this is how the jobs actually arrive, or how the orders came in. So job A came in first. I mean, when you receive order, right? So Mr. A came first. So, and he requested to do a job, and you calculate, okay, you need 6 days. When do you want it? Oh, we want it on the 8th day, right? Then the next job came, B. So this is the, sequence of arrival, okay? Arrival. So when you do first come, first serve, you follow this A, B, C, D, E. But if you do, for example, shortest processing time, how will the sequence become? Okay, Yule, if I say I want to do based on shortest processing time, so what is the sequence going to be like? Which job should I do first? Which job should I do later? I repeat the question. If I want to do the jobs which is shortest first, that means it require less time. Which job should I sequence?
B first maybe,
Yeah, all right. Okay, B, then followed by
then A.
A, which is shorter, C or D or A?
D.
D.
Huh?
or D.
D.
Yeah,
I
D.
missed
Yeah,
that.
I don't understand. So B and then D and then
A.
A and then
C.
C and then E. Okay,
Yeah.
so that is the sequencing based on shortest. If I say, of course, this will follow. Okay, when I say 2, then of course the due date is still the same. Right? The due date doesn't change. Okay, so the job is going to be done on 2 days, and I still have 6 days waiting for the job to be sent to the customer. Understand? Okay, so that is so when we arrange this, right? So let's do the first come first serve first. Sequence is A, B, C, D, E. I told you just now already, because the arrival is A, B, C, D, E. Therefore, first come first serve is A, B, C, D, E. If I do A, B, C, D, E, now the work is requiring 6 days. So the flow time means it will actually complete on the 6th day, right? This is the flow time. Flow. If you start from 0, of course you need 6 amount of time. Okay. Job due date is day 8. So lateness 0. No lateness. Okay. So you move on to the second one. I can only do job B when A is completed. I cannot. No, this is only one process. Okay, one machine or one worker. So flow time is 6 plus 2 actually. Okay, 6 plus 2, and the due date is 6. So what happened now? What happened? So the job lateness is actually 2 weeks. How do you get that? Because I can only complete it on the day 8th, but it is due 6. So there is a 2 weeks lateness. Okay, 2 weeks lateness. Okay, you move on to the C. It is job processing is 8. So 8 plus 8, is requiring 16 flow time. Job due date is 18, no lateness because it's due on 18. Job D is going to be flow time on the 19 because it's 3. Job due date is 15. There is a lateness of 4 weeks. And finally, flow time, for the last, because it's, according to first come, first serve. Okay. Normally, first come, first serve is not, it's not the best option normally. We'll see after this. You can see after this, right? So the due date is 23. So you have 5. So the job lateness total. So you add up 5 plus 4 plus 2. Okay. you can find the average lateness. 11 divided by 5 jobs, you can actually find the average lateness per job. Okay. And of course, you can find the average flow time, or there is this measure. Okay. So that is first come, first serve. Okay, let me just. So the average completion time for measure for FCFS is 15.4 days. 77 divided by 5. Okay, so you get here 77 divided by 5 jobs, which is 15.4 days. Utilization metric is the total job work time divided by the sum of total flow time. Okay, so the flow time is 77. So our utilization metric is 36.4%. The average number of dots in the job system is sum of total flow time divided by total job work time. So it is actually 2.7 jobs in the system. Okay, and the average lateness is 2.2 days. So this is using FCFS and these 4 measures. 4 measures: average completion time, utilization metric, average number of jobs, average lateness. Okay. So this was what you told me just now, shortest processing time. So the sequence is BDACE. Remember? BDACE. Now,
Yes.
so you start doing the job. So you start doing B. So it will be completed. Flow time is 2. The due date is 6. So you don't worry about that. This is 0 lateness. Then once you complete B, you go to D. So this is B. Then you go to D. This starts at 2 and finish at 5 because it requires 3. So due date is 15. No lateness. Okay. Then you start A. So your flow times now goes to 11. Okay, because there's 6 days to do that. Job due date is 8, so lateness is 3. So you're following? Are you following? You see the logic of this, right? So 19, due date is 18, so 1 day late or 1 week late. So this is 5. So from this measure, you do the calculation again, and you can see that the average completion time is 13 days. Let's see whether we have some improvement or not. What was the first come, first serve average completion time? Okay, 15 days. Can you see here, 15 days? 15 for 4 days. By using shortest processing time sequence, I'm able to actually reduce the completion time by almost 2 days, more than 2 days. Now it become 13 days. Utilization metrics also increased 43%. Okay, average number of jobs in the system also increased. Average lateness also reduced. Average lateness reduced. Okay, so shortest processing time is probably better than first come, first serve. Okay, and you do that for the other 2 priority rules. Earliest due date. Okay, if I want to determine the sequence, earliest due date. So what sequence is going to actually happen if I use, we call EDD, earliest due date. So what's the sequence going to be like? Which job should be started first?
B.
Exactly, B. Then
A.
And the rest, okay? C,
B,
D,
C.
E. Okay, this is the sequence. So you only change this now. Okay? The rest is the same. So if you do that, so they become this BADCE, BADCE. And you go through the process of calculating the flow time, lateness, and you will see that lateness has reduced. Yeah, 9 to 6. Okay, 9 to 6. So you calculate the measure again. 13.6 days, 41%, 2.43. Lateness is, better, right? So earliest due date is probably better than even shortest processing time. Okay. And the final one is actually what do you call latest processing time. Latest processing time is probably one of the worst. 48 was one of the worst result. Okay, not longest processing time. Sorry, longest processing time. So your sequence is like do the longest first, and then the second longest. The shortest you do it last. When you do work, when you do your assignment, which one do you do first? Which one will you actually start off with? Logically or normally?
Job due date.
The amount of time that you know, the easiest project or the most difficult project? Normally.
The easier one, I think.
Yeah, the easier one, which is the the so-called shortest processing time. You know, people don't do jobs which are longest processing. You know, that's why it results into job lateness. Okay. Okay. Why don't we take our break? I mean, it's 11 o'clock. Take your coffee. Come back. Have a refresh. Then I will complete some of this, explanation on this sequencing. Hi, go on. Jipun QK shimashou.
Okay.
Okay.